An emergency cut-off switch is not typically required for furnaces in one-story residences. However, there are exceptions. Firstly, if the furnace is located in a basement or crawl space, an emergency cut-off switch may be required. Secondly, a specific code requirement in your area might mandate a switch. Thirdly, if there are mobility issues that may prevent easy access to the furnace's main shut-off valve during an emergency cut-off switch is recommended. If an emergency cut-off switch is required, it should be placed in an accessible and visible location near the furnace. Consider a location at the top of the stairs if the furnace is located on a lower level. Alternatively, consider a remote location, providing additional safety if the furnace is in a hazardous or hard-to-reach area. The emergency cut-off switch must be a dedicated, heavy-duty switch designed to disconnect electrical power to the furnace. The switch needs to be clearly labeled as the furnace emergency cut-off. It is essential to ensure all members of the household know the location and purpose of the switch. Regular testing of the switch is necessary to ensure it is working properly. In understanding electrical circuits, it's important to grasp some fundamental principles. Firstly, voltage, measured in volts, is the electrical potential difference that drives the flow of current in a circuit. Secondly, current, measured in amps, is the rate at which electrical charge flows through a circuit. Thirdly, resistance, measured in ohms, opposes the flow of current. Ohm's law describes the relationship between these three quantities: voltage equals current times resistance. Understanding these relationships is crucial for analyzing and troubleshooting electrical circuits. Let's delve into series and parallel circuits. In a series circuit, components are connected one after the other, forming a single path for current to flow. The current is the same through all components in a series circuit, while the voltage is divided among them. The total resistance in a series circuit is the sum of the individual resistances. In a parallel circuit, components are connected side by side, providing multiple paths for current to flow. The voltage is the same across all components in a parallel circuit, while the current is divided among them. The reciprocal of the total resistance in a parallel circuit is the sum of the reciprocals of the individual resistances. Now, consider alternating current AC and direct current DC. Direct current flows in one direction only, from positive to negative. Batteries and electronic devices typically use DC power. Alternating current periodically reverses direction. The electricity supplied to homes and businesses is typically AC power. AC is more efficient for transmitting electricity over long distances. Transformers are used to step up or step down AC voltage levels. Electrical safety is paramount when working with electrical circuits. Always to energize circuits before working on them. Use insulated tools to prevent electric shock. Wear appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards of electricity, such as electric shock, arc flash, and fire. Follow all applicable electrical codes and regulations. Grounding is a crucial safety measure in electrical systems. Grounding provides a low-resistance path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electric shock. Grounding also helps to stabilize voltage levels and reduce electrical noise. Electrical codes such as the National Electrical Code, NEC, specify grounding requirements for various types of electrical systems. A ground fault circuit interrupter, GFCI, is a device that detects ground faults and quickly interrupts the circuit, preventing electric shock. GFCIs are required in wet locations, such as bathrooms, kitchens, and outdoors. Surge protection is another important aspect of electrical safety. Surge protectors protect electronic devices from voltage spikes caused by lightning strikes or power surges. Surge protectors divert excess voltage to ground, preventing damage to sensitive electronic components. When dealing with wiring, it is important to choose the correct wire size for the application. The wire size must be adequate to carry the intended current without overheating. Electrical codes specify the allowable ampacity for various wire sizes. The length of the wire run also affects the required wire size. Longer wire runs require larger wire sizes to minimize voltage drop. Voltage drop is the decrease in voltage along a wire run due to the resistance of the wire. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Electrical boxes are used to enclose electrical connections and protect them from damage. Electrical boxes must be properly sized for the number of wires and devices they contain. Electrical boxes must be securely mounted and grounded. Conduit is used to protect electrical wires from physical damage and moisture. Conduit is typically made of metal or plastic. Conduit must be properly sized for the number of wires it contains. Conduit must be securely supported and grounded. Circuit breakers and fuses are overcurrent protection devices that protect electrical circuits from damage caused by excessive current. Circuit breakers and fuses interrupt the circuit when the current exceeds a predetermined level. Circuit breakers can be reset while fuses must be replaced. The size of the circuit breaker or fuse must be properly matched to the ampacity of the circuit. Electrical panels, also known as load centers, distribute electricity to various circuits in a building. Electrical panels contain circuit breakers or fuses that protect each circuit. Electrical panels must be properly sized for the electrical load of the building. Electrical panels must be accessible and properly labeled. When troubleshooting electrical problems, it is important to follow a systematic approach. Firstly, identify the symptoms of the problem. Secondly, gather information about the circuit or system. Thirdly, use a multimeter to measure voltage, current, and resistance. Fourthly, analyze the data and identify the cause of the problem. Fifthly, repair or replace the faulty component. Sixthly, test the circuit or system to ensure that the problem is resolved. Multimeters are essential tools for electrical troubleshooting. Multimeters can measure voltage, current, resistance, and continuity. Multimeters can be used to diagnose a wide range of electrical problems. It's also important to understand three-phase power systems. Three-phase power is commonly used in industrial and commercial applications. Three-phase power provides a more efficient and stable power supply than single-phase power. Three-phase power systems typically use voltages such as 208 volts, 240 volts, 480 volts, or 600 volts. Transformers are used to step up or step down three-phase voltage levels. Variable frequency drives, VFDs, are used to control the speed of three-phase motors. VFD can improve energy efficiency and reduce mechanical stress on motors. Power factor is a measure of how efficiently electrical power is used. A low power factor can result in increased energy costs or reduced system capacity. Power factor correction can be achieved by adding capacitors to the electrical system. Harmonics are unwanted frequencies in an electrical system that can cause equipment to malfunction or overheat. Harmonics can be generated by electronic devices such as computers, variable frequency drives, and lighting ballasts. Harmonic filters can be used to reduce harmonic distortion. Understanding the National Electrical Code, NEC, is crucial for electrical safety and compliance. The NEC is a comprehensive set of standards for electrical installations. The NEC is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. It's important to consult the NEC and local electrical codes when designing and installing electrical systems. Some specific NEC sections that are relevant to residential electrical systems include Article 210, Branch Circuits, Article 220, Branch Circuit, Feeder, and Service Calculations, Article 230, Services, and Article 250, Grounding and Bonding. For example, NEC Section 210.12 requires arc fault circuit interrupter, AFSI, protection for branch circuits supplying dwelling unit bedrooms, living rooms, dining rooms, and other areas. AFSI protection is intended to reduce the risk of electrical fires. NEC Section 250.50 covers grounding electrode systems. A grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode system provides a connection to earth for the electrical system. NEC Table 310.16 provides the allowable ampacities for insulated conductors rated up to 600 volts, based on the conductor size and insulation type. This table is used to determine the appropriate wire size for a given circuit. NEC Section 110.16 requires electrical equipment to be marked with the available fault current. This information is used to select overcurrent protection devices with adequate interrupting ratings. The interrupting rating of a circuit breaker or fuse must be greater than the available fault current at that location. Understanding these concepts and codes is essential for ensuring the safe and reliable operation of electrical systems. Always consult with a qualified electrician when working with electricity.